Let's go ahead now and talk about a different sort of radical or exponential format. And in this case, we are trying to talk about the form a to the exponent m over n. Let's see what exactly would that form look like. Now, we already talked about if you have 4 to the 1/2, that is the same thing as square root of 4. But what about 4 to the 3/2? How would you evaluate that expression? Again, we will try and apply rules of exponents here. Let's take a look at 4 to the 3/2. If I choose, I can write this expression as 4 to the 1/2. Okay, I'm still keeping the same denominator and put the 3 on the outside. So basically, I'm saying 1/2 times 3. Okay? If I choose, I can go ahead and break this down in this format where I take 4 to the 1/2 inside and put my 3 on the outside. So I'm basically saying I'm taking the square root of 4 to the 3rd power. Okay, so you can go ahead and rewrite this using 4 to the 1/2 as your square root of 4. And then you have that 3 on the outside. Okay. So you can see how I start breaking this problem down. We first started out with 3 over 2. I break that 3 over 2 down into 1/2 times 3. Okay. And then keeping the 3 outside, I go ahead and combine the 4 to the 1/2, which gives me square root of 4 to the 3rd power. Now we know square root of 4 is 2. You still have that 3rd power outside. And again, if you evaluate this, you end up with 8. So you can see you will end up with 8 as your answer for this expression here. Okay, so to give you a more formal definition for this form, let's go ahead and see what that looks like. Now, anytime you come across this form a to the m over n, remember that m and n are positive integers, where m over n, of course, being a fraction, is in lowest terms. So to evaluate this, you can take a to the m over n as a to the 1 over n, and then put the whole thing in parentheses, and then m as your exponent on the outside. Now remember that since this is a radical term, a to the 1 over n, it has to be a real number. And if your a to the 1 over n is not a real number, then this original expression will not be a real number either. Okay, so that is important when you're working with radicals. Alrighty, let's go ahead and take a look at some examples here. Right, let's go ahead and start with 100 to the power of 3/2. Now, just like it says in your example, we'll go ahead and write this as 100. We'll take whatever the numerator is outside, so you should end up with 1/2. And then 3 will go outside, just like we saw in the earlier example. Now, you can go ahead and rewrite this as 100 to the 1/2 in parentheses and then 3 on the outside. 100 to the 1/2 is the same thing as square root of 100, that to the 3rd power. Square root of 100 is what? 10, right? And then you have that 3 on the outside, so carry that over. And of course, we know 10 to the 3rd power will give us 1000 as your answer. So if you take these expressions and break it down step by step, you can actually understand how this works, and it'll be much easier to work with them. So go ahead and try that same technique on this example here. You have 625 to the 3/4. So again, the same thing, 625 to the 1/4, 3 on the outside. Again, you can go ahead and write this as 625 to the 1/4 and then the whole thing to the 3rd power, which will give you 4th root of 625, the whole thing to the 3rd power. And what is 4th root of 625? So if you figure that out, that will give you 5, and then your 3rd on the outside, or your 3. And then, of course, 5 to the 3rd will give you 125 as your answer. Okay. All right, what happens when you have negative 16 to the 5/2? Now again, you will notice you don't have any parentheses around the negative 16, so that means that your exponent of 5/2 is only on 16 and not on the negative sign. So when you evaluate this, make sure that you keep that negative on the outside, and you'll end up with 16 to the 1/2, and then you can put the 5 on the outside. Okay, and that will of course give you negative on the outside, square root of 16, the whole thing to the 5th power, which will be, of course, we know square root of 16 is 4. Don't forget that negative on the outside. Okay, 4 to the 5th power, and go ahead and evaluate and see what you end up with 4 to the 5th power for. Again, you'll carry over that negative sign, and 4 to the 5th will end up giving you 1024 as the answer. Alrighty. We'll look at 2 more examples here. In this one, of course, you will see that the negative is in the parentheses, which tells us that you need to include the negative sign in your radicals here. Okay? So let's say what happens here. You end up with negative 27 as your base. Your exponent, you can go ahead and write this as 1/3, and then 2 on the outside. Okay, which will give you, since you have negative 27 to the 1/3, that means cube root of negative 27, and then you have that square on the outside. So first go ahead and evaluate what's inside. Cube root of negative 27 is negative 3. Okay, and then negative 3 to the 2nd power. Negative 3 times negative 3, of course, gives you positive 9 as your answer. And let's look at one more example here. Negative 25 to the 3/2, same process. We'll go ahead and break this down as negative 25 to the 1/2, and 3 will go on the outside. And let's see, what does that give us? Negative 25 to the 1/2 is square root of negative 25, and then you have the 3 on the outside. Now here you will see that you end up with square root of a negative number. Now we know that you cannot take the square root of a negative number, so since square root of negative 25 is not a real number, we will say that the whole number here, negative 25 to the 3/2, is not a real number. So there will be no answer to this problem here. Okay, so that should give you a good idea of the different types of examples we have here.